Hello everyone. Today we will introduce a global project, play the Breakout Game using DQN. At first we will introduce our teammate 康凯、程玉恒、戚俊贤、周东浩。And it's a three-part of our presentation. The first one is the background and knowledge from the basic reinforcement learning to DQN. The second part is environment. Our deploy environment includes the Windows 10, the Ubuntu 16.04, and the Python 3.5.2 and the PIP9. And the third part is the building up. It's the process that we building up the DQN by TensorFlow and OpenCV. The first part is the background. The most two basic elements of the reinforcement learning are agent and environment. Within each time t, agent need number one to make an action A, number two to observe the environment, calculate the gain reward, and the environment needs number one the perceived agent's action, number two makes an environment response O, and number three is the feedback chain specifically using the figure on the right to response agent is the brain earth is the environment can be expressed as a quaternary E including XAPR, where X means current state, A means action, the P means state transition. The mixture R means revenue reward. And the main methods of reinforcement learning are one, model learning, for example, the Bellman and the strategy iteration, the value iteration, and number two, the model-free learning, and number three, the value function and approximation, and number four is the simulation learning. The next we could look at the action value function. We define a new function, action value function, after performing action A, accumulate reward using the strategy pi. This is algorithm. This is DQN algorithm. And this is network structure design. Okay, the second part is environment build up. We need the Windows 10, the Python 3.5.2, the Ubuntu 16.04, and the PIP9. And we installing the Windows subsystem for the Linux. This is the process. And the next way, configuring Ubuntu operating environment. And the third part is installing the Python library. It's and the first part is installing the VCXSRV. And the last part of that is to start the project. After the above step are complete, we can start coding to build our project. And the most important part of that is build up the DQN by TensorFlow. And OpenCV for image processing and function color match to binary. The raw input image size is that OpenCV will cut the image to a small size to speed up the convolution natural network computing. It is code. And the TensorFlow for DQN, we intend to use three combination network, the one max port layer and two for connect networks with RMS probe optimize the method to compute the Q value. It is the core code of build the network. This is the code. And in the train network function, after doing the initialization with the self-optimized run. And this is the main function design. In main function, we need to build up the gym environment first and then to looping for each episode. And this is code. This is the process of that. Thanks everybody.
Learning shines in much area such as the AlphaGo, the quantity trading, and the AI game. We think it will be widely used in much area, so we choose this topic as our project. The first difficulty is how to understand the reinforcement learning and the DQN. Exactly, we didn't learn that in the class, and the reinforcement in the internet, which we can find, is also small. So we choose to learn that by the paper, demand paper, and some course in the class. Second difficulty is implementation. We refer to the implementation of many versions of the internet, such as the PyTorpedo and the TensorFlow, and even Scala. There's no image processing, so finally we choose a simple implementation of the idea using the TensorFlow.
The final effect of the project is that after 1 day's training, it can achieve the human standard about 40 points per game. We don't have a GPU, so all the training will be very slow. But if you have a 980 Pi to trade it, we can achieve very good results. We learn the foundation of the reinforcement learning to Q-learning,
Yes.
DQN, and the use of TensorFlow and OpenCV.